When Steve first started talking about this technology, I thought he was nuts. You know, it's something that in school we were always told couldn't be done.
The more I heard about this is this piece, this is this piece, this is how we're doing this, that's how my brain works. That's how it works in my brain.
How come with all the automation that we have in the Western world that the impact in software development was so low? What's different about software? What's wrong that we can't apply automation to software?
This is something that can affect anyone who develops software. It's not just someone who has 30 years of experience. It's anyone who wants to program and have their job eased.
When you look at software, you know, people say, well, I could code this program 1,000 different ways or 10,000 different ways, and they're right. And they look at that complexity, and the conceptual barrier they have is how can you take something that's so complex and analyze it and automate it? And the answer to that is that without the math normalizes it. We take the chaotic structure of software and normalize it in a way that actually you can do automation on it. People think it's complex, but without the math, you can't see the inner order to a software.
What happened when I was doing this in particular, I woke up in the middle of the night and I realized that the way I created this to try to understand our system is exactly the way we're going about implementing the artificial intelligence to do the same thing for people. The problem with this is it took me 60 hours, it's out of date. As soon as we've changed our code, this is out of date. If the system can do it in seconds, then you keep getting an up-to-date answer about your software. Revolutionary.
Automation is always something that drastically changes the way the world acts. So if we're able to automate software engineering processes, it's hard to identify exactly how it changes the world, but it's definitely a world-changing event.
I had that aha moment that said, hey, the technology we're developing can be used in this example. It can be used in embedded systems, it can be used in large application softwares, it can be used by an intro to CS student.
On the planet, it's a $2 to $3 trillion industry. Every single application of it will use this technology. That's why we're so excited about it, is because it's broad applicability. And the theories that we're using, doesn't matter what industry. It could be mortgage, could be aircraft, aerospace, could be military, could be healthcare, all across the board.
With hundreds of millions of lines of code with different systems hooked together, some are new, some are old, it's a huge problem. Our software is going to extract exactly what it does and then be able to tell exactly what the difference is after we change it. That can't be done right now.
What this does is it brings software up to the same level as the other industries. Improves the quality and improves the productivity, and it makes it coherent. That's the impact.